Hello boys and girls, welcome to Mrs. Bandu's Math Movies. This is for Algebra 1, Lesson 4-6, Absolute Value Equations and Inequalities. Our objectives are to solve equations that involve absolute value and also to solve inequalities that involve absolute value. Okay, so our key concepts are organized for us right here. To solve an equation in the form the absolute value of A is equal to B, where A represents a variable expression and B is greater than 0. We're going to solve A equal to B or A equal to the opposite of B. Solving absolute value inequalities. To solve an inequality in the form A is less than B, where A is a variable expression and B is greater than 0, we are going to solve this compound inequality. The opposite of B is less than A, and A is less than B. Okay, and finally, let me focus that a little better. To solve an inequality in the form the absolute value of A is greater than B, where A is a variable expression and B is greater than 0, A is going to be less than the opposite of B, or A is greater than B. Okay, so you are going to need to, particularly these two, this one I think the equation is pretty intuitive. The inequalities, though, you're going to have to memorize or learn the difference between less than absolute value inequalities and greater than absolute value inequalities. One comes out as an and statement, the other is an or statement. The greater thans are the or statements, less thans are the and statements. Also, just to note, similar rules apply for the absolute value of A less than or equal to B and the absolute value of A greater than or equal to B. Okay, let's look at some examples. Also, this is a section where you might actually want to make it a point to go into your textbook and read through some of that information in there as well, just to clarify or to give you more varied examples of what we're doing here as well, in addition to what we'll do here and in class. Okay, so we want to solve and check the absolute value of A minus 3 is equal to 5. Okay, so the first thing we'll do is we're going to add 3 to each side. So the absolute value of A is equal to 8. So that means A is 8, or A is the opposite of 8. And this is by definition of absolute value. We talked about that earlier this year. Okay, so to check, the absolute value of 8 minus 3. So 8 minus 3 is 5. So here we substituted in 8. Here we're going to substitute in negative 8. So the absolute value of negative 8 is 8 minus 3 is 5. So we see that in both cases it checked. And you do need to check in both cases, because if you make a mistake, hopefully it will help you catch it, particularly with the inequalities. Okay. Solving an absolute value equation. So we want to solve, that'd be helpful for you to see, wouldn't it? The absolute value of 3c minus 6 is equal to 9. So you write two equations, one where 3c minus 6 equals 9 and 3c minus 6 equals negative 9. Okay? And we're going to add 6 to each side. I'm going to go ahead and work the left-hand one first and then the right-hand one. You could jump back and forth, but it would probably get pretty confusing. So let's try not to do that. So again, I'm trying to my first thought is to isolate my variable. So 3c equals 15. And in this case, I'm going to divide each side by 3 to isolate C, so C is 5. Okay, so that's one of the values of C. Let's go to our second equation, 3C minus 6 equals negative 9. So here, again, we're going to add 6 to each side. 3C equals negative 3. So again, I'm going to take each side and divide by 3. So C is negative 1. So what that tells me is that the value of C is 5 or it's negative 1. And you can take it and substitute into the original inequality. I'll just talk through it. 3 times 5 is 15. 15 minus 6 is 9. The absolute value of 9 is 9, so the 5 checks. If I put in negative 1, 3 times negative 1 is negative 3, minus 6 is negative 9. The absolute value of negative 9 is 9, so that checks as well. Okay, so again, even if a check is not required, I highly recommend doing at least a mental check so that you don't make any careless mistakes. Okay, here we go. We want to solve the absolute value of y is less than 5. Oh, excuse me. Let me start over. The absolute value of y minus 5 is less than 2 and graph the solutions. So we write our compound inequality. So y minus 5 is greater than or equal to negative 2, and y minus 5 is less than or equal to 2. Okay, so we will add 5 to each side, and again I'm going to work one and then the other just to keep things somewhat less confusing perhaps. So in this case I'm going to add 5 to each side, so that gives me y is greater than or equal to 3. On this side, if I add 5 to each side, I get y is less than or equal to 7. So y is greater than or equal to 3 and less than or equal to 7. To graph that, I'm going to have a solid dot at the number 3 and a solid dot at the number 7. It's an AND statement, so I will shade in between the 2 points. Moving on to the next one. The ideal diameter of a piston for one type of car is 88.000 millimeters. The actual diameter can vary from the ideal diameter by at most 7/1000 of a millimeter. Find a range of acceptable diameters for the piston. So that means basically they're expecting a particular size of piston. It can be smaller than that or larger than that by at most 7/1000 of a millimeter. So let D equal the actual diameter in millimeters of the piston. So the diameter minus 88.000. The absolute value of that is less than or equal to 7/1000. Okay, by doing absolute value, we take care of whether it's over or above, all right? And then it gives us less than or equal to, because it can reach this, but it cannot go over the 7/1000. Okay, so our inequality is the absolute value of D minus 88.000 is less than or equal to 0.007. So we're going to write a compound inequality. So D minus negative 0.007 is less than or equal to D minus 88.000, which is less than or equal to 0.007. Okay, so basically this is what was in the absolute value symbol. If it's smaller, you would subtract. In other words, to show that it's smaller than 88.000, we would subtract this much, so it could be that much smaller. This is showing where it could be that much greater, so that's why you have that. Okay, now we want to add 88.000 to each side of, or each position in the inequality. You can break it into two separate ones if you'd like, or just work it as three columns here. A little bit less writing maybe to do it this way. Please do whatever makes the most sense to you though. Okay, and when I do this, the math over here gives me negative 0.007 plus 88.000 is going to be 87.993 is less than or equal to the diameter, and the diameter is less than or equal to 88 when I add these two, 88.007. So what that tells me is that the actual diameter must be between 87.993 millimeters and 88.007 millimeters inclusive. In other words, it can be those measurements as well. Again, this is if it's under or too smaller than ideal. This is if it's over or larger than ideal. Okay. All right. That is, I think, our last, yes, that was our last example. You have several quick checks to work through. If you'll please have those ready next time we meet in class. I look forward to seeing you then. Please